Today we continue to do with the code, C++ code, how to simulate the lidars, and especially how to see how it look like on the simulation, the laser beam, and how we can change the parameter to get the higher resolution for the laser beam. We student, we don't have too much the money for get the real data lidar to practice, right? So here's a good tool for you to practice with the data point. It means the BCL on point cloud, right? So it's help you to get the data and you separate segmentation, filtering, range set from the blank cloud or the object cloud. Okay, the obstacle cloud. We can separate between them. Okay, clustering. Okay, and look like what I mentioned the last video. We will have the simulation something like that, and we can change the parameter to get something like this. Okay, this is low resolution is really high resolution. Okay, lidar. Okay, and we also get the data point in the simulation. Right now we don't show the ray, the laser beam. We show the point, the data points on the simulation. Right here we can see the obstacle right here, the car right here. You can see the roof, the car right here, point is here. This show the roof, the car. But in the code we can skip this part because it's a roof, so we don't care this point so much. So how about this one? This obstacle and another vehicle right on the road. This one too. That's in here is the real data point which impacted by the noise. So go back to the code. You can see three main code right here. In the environment code, we create a viewer and from the BCL library with the visualization type. Okay, and the name is viewer. Okay, from viewer we pass this viewer into the function to get the car, the lane, or whatever you want. Right. For example, right here we pass viewer into the initial cam function to get a camera view for you. Okay, and for example, we have the simple highway. How they create the highway or traffic on the road. We pass the viewer into this function. Okay. For example, initial camera, you need the viewer. Okay, right here you pass a viewer. Okay, here is the type. Right. Remember this is a type, and the bus reference. I mean every train outside inside the train too. And right here you can see we can set the background. Okay, for viewer we can set the parameter for what kind. It depends which one you want. That's why I love to show you right here. And another thing is the simple highway. We call create the simple highway with three car. Okay, so how we see we pass the viewer to into the function simple highway, and right here we return to the car right here, car, and they get the initial highway right here with the viewer. Initial highway they show us we also pass the viewer reference right here, and they show all the car, three car and one eagle car. This we have four cars right here, and return the car, and we put the render scene right here for boolean right here. To turn it up to switch from the laser beam to the data points, BCL point. Okay, BCL. And okay, and another thing I mentioned last time, we mentioned a lot of the template right here. We create a template that's one time I can reuse for different type of variable in the BCL point cloud data, right? So right here you see, I hope you read it and figure out how it's work with the template. With Ponty, we can see Ponty a lot in the code because right here we can use with the XYZ or XYZI or XYZ RGB, or we have the many kind of the type in the BCL library. So we just write the template one time, and after that we reuse this code. Okay, that's the benefits of a template. So template, we have a lot of function right here. So we will figure out in next video in each one for future segmentation range set or for KD3 or a lot of stuff or test something like that. And another from right here, this the render is help us to create the shape of the bus, the road or the highway, the cube. Or right here you see viewer they add a cube shape. I mean this function will help us draw the object on the viewer, right? Uh, the more important thing, the important thing is class right here, lidars. Lidars, we also have the stroke lidar, the lidar object right here, right into stroke, right? I hope you understand the stroke in the object-oriented programming. We the lidar when you put the lidar object into the car, when they know the position, okay, and then so now the min mass distance, the resolution, the noise right here. Okay, in the lidar, there's function right here. Okay, they have the car, what the car you want to set lidar there, and the slope, okay, ground slope, the incline of the laser beam. So we also change right here. We change the parameter right here to get the different resolution of the lidar. Okay, right here you can set the noise. Okay, 0.2. Okay, and we can get the number of layers in the range, vertical range. Maybe you forgot it. I show you again right here. The range angle right here is different layer. Maybe we can change to 3A layers. Okay, it's more high resolution. So you can change right here. Okay, horizontal angle inclination. Okay, pi over 64 is really a lot. Okay. And that's it. The lidar in the lidar's object you also have a scan lidar, okay, and scan right here we don't have any argument. Let's create the laser beam for the lidars right here. We use the ray object right here and return the cloud, okay. And let's see how it's work in the code, okay. Right here we create the car. We have call the object car. We create the eagle car 1, car 2, car 3 with different vectors. Okay, we pass into the viewer. Okay, and render highway. You see, we have the function render highway. Right, I already showed you last time. So symbol highway. Right now we have how to see the symbol highway. We create a symbol highway function right here. So we write this is true, right? It's true mean we can see the laser beam. Last time we want to see the point cloud, it says 4. They create a point cloud for us. And right here we call the initial highway with the view, okay? And we call the object lidar with the pointers, okay, type. And this is the heat, right? We pass into this lidar or the cars and the slope. Ground slope is 0, okay, and we got the pointer. You see this one, the pointer type point cloud at the BCL library. We call points. So let me see, and we call the render race, the viewer position, and this one, okay. The point cloud right here, the name point cloud right here, okay. In the main, I was show you one time we create the viewer, okay. Visualization the viewer to the window, okay. Show the simulation, and we set up the initial camera how we see it, and we call symbol wave viewer, and it show the viewer. And in the Linux system, I want to show you. As some you don't know about how to run the code, I want to show you how to run the code. Okay. You had to go to the folder, okay. Go to the folder contain the executed files. And you see you had to create the build folder. You use mkdir and create the folder view, and you go to the cd view, and after that you create cmake.dar, and they create the executive file for you, and after that you say make, they had to create the executive file for you. If something error happen, they show you. Okay. Alright, we have the file right here, environment. You can see how the executive file, you can say ls, they say the file executive file right here. So how to run the file? That's dot slash and environment. Let's see. All right here. Where the cars? So let's see something wrong. Set the angle. Render is true. Render race. Lidar pointers new PCL. You see, we replay in the main with the type we want. Last time we write pointers, right here we use the point PCL column points XYZ pointer. For example, what we say input clouds, and we say viewer lidar. We call the function position. Okay, and we say don't change to map right here. STD vector cross right here. Okay, call the initial highway. Okay, that's a curve. Let's read Mac again. We call the lidar objects. Okay, you can see, we can see this one. You can use the mouse to see how your lidar. Okay, you can rotate and you see how your lidar right here. Right here, you can see it's really high resolution. What happened if we change resolution? We go back to the lidar right here. You see in the lidar they build the stroke ray, okay, and they build the stroke lidar right here. You see they build the function this lidar in the car, what car, and slope of the laser beam, mean mass right here. You hear an asteroid right here, for example, the number layer with the three layers, and right here we got the power 6. How they change? Okay, let's see. We run again. Okay, you see right now they already changed. You can see with the lowest resolution with the 3 layer laser beam. Okay, and they point to the car, but it's not good, right? Okay, we had to increasing the resolution. We got the more data points on the car, the object car, and we know what property of the object, right? And here, okay, zoom in, zoom out, zoom out to play with that. That time and one more thing I want to show you, how about in a man right here we call view symbol highway, but right now we see the laser beam. But if you don't want to see the laser beam, right here I change it, come back again, for example the A, and we divide increments. Okay, 60 horizontal vertical increment right here is 4, and back to environment. Right now I don't want to see the laser beam, I want to see the point cloud data points. How we change it? So right here we don't need to render rays. We say I want to render point cloud right here, and right here you want to see the impulse clouds right here, right? And where this function, and right here you say I don't want okay, and where this function, okay, you go to the renders, they have a function where the render right here, they have CBP render CBP, they have a render highway for you. They have a lot of the function render array, they create laser beam for you, and render point cloud right here. We call this one, now I don't want to see one render rays, I want to see the point clouds on the simulation, so I call this function. Okay, this function they pass reference the viewer, and then so you see right now you see how's the benefit of the template. We call the PCL and put on the SYZ, but next video we use the SYZ I right here. We need the information intensify, it means the intensity of the value. Okay, and we pass reference the clouds. Okay, and we put string the name right here and colors on the cloud right here. That's the function to render the point clouds. Okay, go back to environment to see, and we right now say render point cloud viewer, the input right here and the name, string name right here. Okay, right here the same thing. Let's make it again. Okay, let's see. Yep, you can see how the point cloud generate in this case. You see, right now I forgot to turn it off the traffic car right here. But anyway, this one is help you easy understand from the point cloud. They generate from ego car. They hit to the traffic car right here. You see? Okay, they got the point cloud right here. Okay. All right, now let's turn it off. Turn off the traffic car. How we see the point cloud right here. As I say, for why? Because for right here, it means I turn off the car right here. Is this one strong, right? So they don't generate the car and the traffic. Okay, let's see how this look like. We run back again. The practice do on the Linux system is help you a lot. After that, you can combine with the Python matplotlib in the C++. It gives you really good visualization in graph. And in the execute file. Right now, you can see. You see, right here is the point cloud. Right, the point cloud. You see it right here. You see it right here's object, the car on the road. Last time we already see that. Okay, another car right here, right, and right here. And you see right here the point cloud radar is really not smooth. I mean a lot of noise. When you put a noise into the code, right? If we don't put a noise code, really smooth for you. Let's see. You go back to the lidar, you can change the noise right here. Just say 0. Okay. Run the code. You see, it's feel not without a noise. It's really smooth. It's really good. The data point right here, the car right here, and another car right here. You see. Okay. That's it, right? Without a noise, really nice data point, right? But in the real world, it's a lot of noise impact on the data points. So here's a good tool for to practice with the data points, how to handle with the data from the lidar. I want to share with you. What I learned now. I try to share everything I know about the autonomous vehicle for you. And that time we already had the obstacle right here. We had the everything with data point, everything. How we separate this object in with the another object, how we separate from right here. Now object is mean the plane, right, surface, the road. How we separate this object and the surface. We use a lot of algorithms, segmentation, filter, ransack, or KD trees, and clustering. How we separate the two kind of object. Okay. For the next video, and we go deeply into the this process of point clouds CBP. In this one, we had to go detail for each function of filter cloud, okay, and allow stop clustering, okay. So right here, I hope you can run the code and see how it look like.